Good morning. Welcome to Rogani College of Engineering and Technology. I am Reggie, Associate Professor, Department of EC. Today we are going to see about microwave passive devices, directional coupler. Once they will know the microwave passive devices, students will be able to what are microwave passive devices and you define directional coupler. In that, so we are going to see about what is a history of S parameter. If a circuit consists of linear element, then it is represented by a set of linear equation relating the independent quality like voltage current to a dependent quality also voltage current. At a higher frequency, the concept of voltage and current become more difficult to relate the network performance, especially in network using transmission like waveguide. S parameter are related to power waves and avoid a lot of issue. S parameter refers to scattering matrix of microwave network. Consider a two-port network as shown in figure. If the power is applied to one port, most of the power escapes from the other port. So it reflects back in the same port. Hence the figure V1 or V2 is applied or I2 or current applied. The wave traveling is associated when scattered out through the port. Microwave junction can be defined by S parameter or scattering parameter, which are represented in matrix called scattering matrix. It is a square matrix which give all the possible combination of power relationship between the various input and output port of microwave junction. The element of the matrix are called scattering coefficient or scattering parameters. If I want to measure SOS1, we inject a signal at port 1 and effect it reflected back. In this case, no signal is injected in port 2, so A2 equal to 0. For almost all laboratory S parameter measurement, we use inject one signal at a time. If you want to measure S12, we inject a signal at port 1 and measure the resulting port 2. Hence S12, we inject a signal into port 2 and measure the signal after leaving port 2. And S2, we inject a signal port and measure the reflected signal. S parameter, we would assume that one port with reference to impedance is at not. We will define the 4S parameter. S11 equal to B1A1, S12 equal to B1 by A2, S21 equal to B2 by A1, S22 equal to A2 by B2. The above S11 and S2 can be derived for the network analysis or measured by setting the incident signal A2 equal to 0 and solving the S parameter. S11 to S22 are derived by the set of value and solving the equation. So the matrix for a single port S11, two port S11, S12, S21, S22. For three port S11, S12 to S13, S21, S22, S23, S31, S22, S33. S matrix is a square matrix. S matrix is a symmetric matrix. S matrix is a unitary matrix. The sum of all product each time multiplied by the complex conjugate by other is equal to 0. First is E-plane T. E-plane T is a junction formed by a single waveguide to broader dimension of rectangular waveguide which is already have two port. The arm of the rectangular waveguide collinear arm. Port 1 and 2 which is new one. Port 3 is called side arm or EM. This plane is called series T. As the axis of the side arm is parallel to the electric field, junction is E-plane T. The port 1 and 2 are already out of phase with each other. Consider a 3 cross 3 matrix. The scattering coefficient of S13 and S23 are out of phase bound. So S23 minus S13. If you substitute for the symmetrical port, is perfectly matched. S33 equal to 0. So symmetric property S12 equal to 1, S13 equal to S31, S23, S32. So S matrix can be for a E-plane tree, port 1 and 2 are out of phase by 180 with the input of port 3. Hence scattering combination S32 equal to S32 equal to minus S13. So substituted in the 3 cross 3 matrix, you will get S11, S12, S13, S12, S22, S minus S13, S13 minus S13, 0. So if you apply the property, unitary property S into S star equal to 1, so you will get the value R1 and C1, R2 and C2. You multiplied R2 C2, R3 C3, R3 Z1. And if you compared, you will get the value S13 equal to 1 by root 2 and S13 not equal to 0. So S1 star equal to S12. When you substitute here S11 equal to 1 by 2, substitute all the matrix, you will get the value of the S parameter. So B1, B2, B3 equal to 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2 minus 1 by root 2, 1 by root 2, 1 minus 1 to 0 with A1, A2, A3. Similar way for H-plane T. The H-plane T extension is found by attaching a single waveguide to a rectangular waveguide which is already have two ports. The arms of the rectangular waveguide which make two ports called collinear port. Port 1 and 2 which is new arm. Port 3 is called side arm or H arm. This H-plane is called shunt T. Hence the axis will be perpendicular to the parallel to the magnetic field. The junction is called H-plane T. Consider a 3 cross 3 same as E-plane T. Here S13 and S3 are equal, so Sij equal to S2. Here you will consider only the value S33 equal to 0, and another one, if you multiply with the row respective column, you will get R1 C1 which is equal to 1, R2 C2, R3 C3, R3 C1. So S13 equal to 1 by root 2, S12 equal to S22. So S12 equal to minus S21 star. So S1 equal to 1 by 2, S12 minus 1 by 2, S22 equal to 1 by 2. If you substitute here, you will get B1, B2, B3 equal to 1 by by 2 minus 1 by 2 1 by root 2 minus 1 by 2 1 by 2 1 by root 2 1 by root 2 1 by root 2 0. Magic T. The E-plane Tee junction is formed by attaching two simple waveguides, one parallel to the other series to a rectangular waveguide which is already have two ports. This is called Magic T or hybrid a 3 dB coupler. The aim of the rectangular waveguide make two port called collinear port. Port 1 and port 2, where port 3 is called summum and port 4 is called difference sum. If a signal of equal phase and magnitude to port 1 and port 2, then the output port is 0 and the output at port 3 will be additive. If the signal at port 4 EM, the power is divided between port 1 and 2 equally but opposite in phase. There will be no output at port 3. If a signal is fed at port 3, the power is delivered from port 1 and 2 equally and there is no output at port 4. If a signal is fed at one of the collinear port, then appear no signal in the collinear. Hence EM produce a phase delay and HM produce in advance. So this is the S4 cross 4 matrix. So 4 possible inputs. So S matrix is 4 cross 4. So assuming all the condition, you will get S matrix equal to 0 0 S13 S14 0 0 minus S13 S14 S31 S32 0 0 S41 S42. So 0 0 0 0 and substituting the value of S13 you will get 1 by root 2 0 0 0 0 1 1 minus 1 0 minus 1 minus 1 1 0 0. E-plane junction is used to measure the impedance. A null detector is connected at the E port and the microwave source connected is to HM. The collinear port together with this port make the bridge and the impedance measurement is done by balancing the bridge. E-plane, H-plane is used as duplexer. E-plane is used as mixer. These are the advantages of E-plane. Directional coupler. Directional coupler is a device that samples a small amount of microwave power for measurement device. The power measurement include incident power, reflected power, VSWR. Directional coupler at port 4 waveguide consists of primary, main and secondary, auxiliary, secondary. So consider the properties of directional coupler. So PA is the incident power, PR is the received power, PF is the forward power, PB is the back power. At the termination are matched when the port travel from port 1 to port, some portion get coupled to port 4 but not port 3. As in bidirectional coupler, when the power travel from port 2 to port 2, some portion get coupled for 3 but not port 4. If the power is incident through port 4, a portion of power is coupled to port but not port 1. If the power is incident to port 4, a portion is coupled to port 1 but not reflected to port 2. Port 1 and 3 are decoupled with port 2 and 4. Coupling factor. Coupling factor of directional coupler is the ratio of incident power to the forward power. It is measured in dB. Directive to directional coupler is defined as the ratio of forward power to back power, measured in dB. So types of directional coupler. There are different type of directional coupler: 2-hole directional coupler, 4-hole directional coupler, swing-chair coupler, and 3-hole directional coupler. So 2-hole directional coupler, spacing between L is equal to 2n plus 1 into lambda g by 2. So it is having primary waveguide, secondary waveguide. So S parameter of the directional coupler will have S11, S22, S33, S4 equal to 0. So S13, S31, S24, S4 equal to 0. Since there is a no coupling between 1 and 3 and 2 and 4. So you substitute out the value and you have to determine, apply the properties of S parameter. You will get S11, S1 star plus S14, S4 star equal to 1. So when you substitute the value, you will get S12, S14 and S33, S34, S21, S33, S41, S43. S12 is equal to S34, S4 equal to S23, S12 equal to S4 equal to P. So we know that P is the positive and real. Then P square plus Q square equal to 1. So S matrix is a direction coupler related to 0 P, 0 JQ, P 0, JQ 0, 0 JQ 0, P JQ 0, P 0. Directional coupler problem. Calculate the coupling factor of the directional coupler is 900 watt and the power in auxiliary vector. P1 equals 600 megawatt. P4 is equal to 350. So C equal to P1 by P4. You calculate, you will get 32.4B. So another problem related to directional coupler. Calculate the power at the main amp and auxiliary amp. So coupling C equal to 10 log P1 by P4. You will have the value. You can calculate power in auxiliary amp 500 megawatt. Now power in main amp, output power and input power, output power plus auxiliary power. You will get 549.91 milliwatt. So these are about the directional coupler, types of directional coupler. Thank you.